第二定律的时候，我们的主角永远是质量 ，OK？ 但是你现在在分析用有限元的时候 ，OK？ 你的主角不是质量，你的主角是节点。So in this case, the analysis is not done on the mass, but on the node. You concerned about the displacement on top of the spring and on the bottom of the spring. Okay, so we have Newton's the force balance. Okay, force balance for the force balance for the spring. And then now, if the end mass got the acceleration, how are you going to model this? Okay, let me redraw this to give you an idea. Okay, in this previous model, you have a spring, okay, on the two ends. Okay, if this is x1 and this is x2, and then you are going to be subjected to force F2 and F1. Okay, so you stand at the point here, in the view here. Okay, then you see the force balance on this point. Then you see force sum equal to 0. Then you kind of feel that, oh, my external force is F1 down. Okay, if I move it down with x1, then I'm going to be subjected to an upward force. What's the upward force? Okay, this upward force is K x1 minus x2. Okay, so this is knot 1. And then for knot 2, you also write the same. You have your F2 minus K x2 minus x1. Try to recall how you wrote for your formula. Okay, so if you wrote it the other way, okay, wrote it to the other side, then you have your F1, F2 is equal to a stiffness matrix K x1 x2 minus K minus K K. Of course, you can rewrite this rather than using X. I can now use the displacement U, okay, for replacement. What you learn about is a static analysis. Okay? And how about the dynamic analysis? in the case of dynamic analysis, okay, your if let's say the mass is located here, okay. Previously, you are writing F2 minus K U2 minus U1 equal to 0. If this point is going to subject to the acceleration, the formula here is no more 0, it is N U dot. Okay? So meaning these two equations are similar, but I have to rearrange them. How do I rearrange them so that it's solvable? Okay, as we did, we write these external force F2, but now we MU2 dot is equal to K U2 minus U1. Okay? So how do I turn these equations into a dynamic equation? Okay? I turn it by adding an extra term. This is my 0 and U2 dot. Okay. 所以同学看到没有？这个是因为我额外调重。调重就在端点。So in this case, this is the Coulomb force, Coulomb inertial force on node 2. Okay? This is perfectly fine. Okay? No problem. Okay? That's because all the force is lump on node 2. But it's not fine if the mass is distributed along the spring. Okay, but that's still fine. If I say, how about split the mass half on the top node and half on the bottom node? Okay. So how do we divide the mass? Okay. So this is kind of like doing even distributions. Okay? So this is your rationale. So if that's the case, then you're going to rewrite the term. If you split up, then you have N over 2 U1. This is an additional term. So actually solving for this could be complex. You have to do the acceleration term, you have to do numerical analysis. But for us, my main concern is, will you be able to find the mass to be lump on each node? 所以现在我们比较关心的是，你怎样把这个惯性力加上去？所以这个是静态力的平衡，重力跟弹力相抵消。OK， 然后接着呢是，你如果有加速度，而且这速度是这个端点2上面质量块的加速度，那你要额外加一个 y， 就是 m2 加上 mg， 或者加上这个加速度。OK， 那如果没有加速度，那就不用。Okay, in this case, you can reorganize your equation if you're going to do the solutions. Okay, because one of the concerns is most of the time u is not known. Okay, then acceleration of the u also not known, so you have to do them in one loop. Okay. So this is telling you how to write the equations. If the equations got a force excitation, okay, then your solution is going to be this form. Okay, if you have multiple nodes, how do you do the solutions? Okay, you have to do the force sum on each node. On node 1, there is a spring force balance with the reaction. On node 2, there is a spring force coming from the top spring, bottom spring, balance with the weight and balance with the inertial force due to the mass of node 2. How about the force balance of the node 3? Force balance of the node 3, there are only one mass, there are only one spring on the top, then there is a balance, yeah, like this. And then, yeah. 所以看到没有？所以我们这个有限元素为什么是跟振动学当年是一起的？因为振动学的分析方式就是在质量点上 ，OK， 然后所有的力合，那这个质量点就刚好在节点上，而不在弹簧上，弹簧上有两个点 ，OK， 所以这个分析跟有限元素是一模一样的，所以有限元素的出现不会 surprise。Okay, yeah. So even the approach we solve for multiple degree of freedom in the vibration is we write out the equation. Okay, on node 1, node 2, node 3, and then now we re-express these equations into mass matrix and acceleration vector plus stiffness matrix and displacement vector and equal to the force vector. This force vector is a reaction, it's the weight of each node, okay, and then you're going to solve for that. Okay. And then next, how do you reduce the problem? This is kind of assistant matrix for all three springs, okay? But indeed, okay, or two springs, okay? You can apply the boundary condition. What's the boundary condition? The top node is on the support by the ceiling. They are not moving. So in this case, the only free degree of freedom is U2, U3. Likewise, acceleration 2, acceleration 3. Then you have a mass matrix and acceleration vector plus stiffness matrix and displacement vector is equal to the force sum. So in that way, you are able to reduce the problem into these simple two-angle equations with two unknown solutions. Here, the unknown solution got to be expressed as a sine function because it's vibration. It's not a static value. So what's the amplitude of vibration? It's A2, A3. And assume that there is no damping, then the oscillation will be in phase. The acceleration after can be expressed, okay, your displacement can be expressed as an amplitude vector times sine function. If you now do time differentiation twice, then you're going to have the acceleration of node 2 and node 3 is equal to minus omega n squared times A2, A3, okay? So what is this? Okay, let me draw out. When something is oscillating, okay, if you draw the, okay, what is your U1? Your answer is going to be an oscillation, okay? And how much is your amplitude? This is your A1, okay? This is your A1. They are going to be equal. Then they repeat itself by every period. This is the time taken from peak to peak. Period is the time, also for the period. Okay? This is peak to peak. Okay? And as a result, your sine function will complete one cycle. Okay? This is a period. Okay? And this is defined as omega, which is 2 pi divided by the period. This is the angular frequency, okay, rather than the normal frequency. Okay. So in this way, okay, if now you want to find the natural frequency is what? Is the period. You can obtain it by setting the determinant to be 0. Okay, so that where there are no force applied, they are still oscillating, but the amplitude is non-zero. That must have 0 divided by 0, so that your answer A1 is non-zero. In this case, your natural frequency can be determined from the sum of this stiffness matrix plus mass matrix. Okay, so this expression will give you the natural frequency. Okay. OK， 同学这个有感觉吗？没有感觉的话，我们看一下一个短片。来猜猜看，现在有2个海绵装在一个弹簧上 ，OK， 然后我上面手提着它，我往上扬，我往下降，然后这个弹簧上面的海绵，它会一起上一起下吗？还是会一上一下？告诉你。这2个海绵是齐上齐下，还是一上一下？看得出吗？猜看，来，一上一下的举手。齐上齐下的举手。OK， 好，为了让这道题比较形象 ，OK， 所以我们可以在这个，如果有实体的话，可以在这个上面装一个上嘴唇，下面装一个下嘴唇。它是合不拢嘴，还是开了又合？我们来看一下。再看一遍。这个有实体的话，可以做实验。再看一下。如果说它是一上一下，那个嘴巴会合上 ，OK， 然后合了又开 ，OK。那如果是齐上齐下，那嘴巴就是张得老开的，不会合上。我们来看看这个解答。OK， so we shall see the rapid motion of the book. OK， 看到没有？低频是齐上齐下，所以嘴巴合不上。然后频率稍微提高，所以这个0.8赫兹是齐上齐下，所有的 upper lip and bottom lip cannot touch. Okay, if you now increase the natural frequency, driving frequency, then you can make sure that they are open, close with the upper lip and bottom lips. Okay, yeah. So this is the sign. Okay, and then next, regarding the vibration, you can also see them in the building. 好，刚才看到的是这个上唇跟下唇的震动，然后我们看一层楼这个它的这个共振。Okay, if you now have one story building, one longer pillar, we have lower stiffness. Okay, so how do you determine the stiffness? 振的话是这个，现在是高频的共振，低频的共振。好，我就以这个为例。How do you determine the natural frequency? I'll take this example for the analysis because some of you never see this before. Okay, let's use the equation. Since you all have learned about the structural analysis, this structural analysis to you is peanut now, okay? But what is new is the inertia. OK， 所以同学解这道题应该太简单了吧，对不对？那你把它分解了，含黄再加质量 ，OK， 作用在这个弹簧上的是 F， 作用在质量上的是 F 相反，只是你后面你可能有加速度，所以 the thing when you are analyzing one single mass spring, okay, we're going to do it using the finite element way. Okay? So if you do this in the finite element way, you can write k 1 minus 1 minus 1, 1, and then what's the displacement? Okay, I will change it. This is U2, this is U2 for the bottom, U1 top. Then what are the forces? Forces here is, okay, top is bounded, so your reaction force. And then bottom, is it 0 when you excite the, okay? When it's going free vibration, there is an inertial force. And this inertial force is your 0 minus N U2. Okay? And supposedly, if there is mass on top, you should write it as well. So another way of writing this is, okay, is 0, 1, U1 double dot, double dot. 同学看到了，我们今天全部都以矩阵的形式来写，这个叫进度矩阵。你们有些人解到很多了嘛，对不对？明明这里叫做惯性力 ，indeed this is inertial force, okay? But I still write them in the matrix form. In this case, this is what's called mass matrix times acceleration vector. Okay? Why do I write them that way? Because if I write them that way, okay, then I can do grouping. Okay? This is 0, 0, 0, n times this acceleration vector plus the simplest matrix and displacement vector and equal to the reaction force and the rising side force vector. Okay, this is modeling mass on the support and then undergoing free oscillation. 学看到吗？哎，如果我给你这个解，它的辅值就是 a， 这个 u 等于 a sin omega n t omega 是什么？我是不知道，这个大概应该就是2个派除以一个周期等于2个派除以角频率，这 omega 是角频率。那我要怎么从上面去解这个值呢？How to solve this problem? Okay, so to solve this problem, I will single out the one with free degree of freedom. Okay, this is the one free, this is the one free. You add it up. Okay, mass time U2 double dot plus KU2 equal to 0. Okay. 就意味着看懂吗 ？OK， 然后现在我们要找 U2 是什么 ？What is U2？U2，OK， acceleration for U2 is U2 double dot is equal to minus a omega square sin omega t。OK， 如果同学对这一步有点陌生，不打紧，你如果说直接微去做次微分 ，OK， du2 dt is equal to negative omega positive omega a cosine omega n. If you differentiate it twice, du2 dt second time, it is differentiation of cosine a minus omega square a sine omega n. That is how you want it. Okay? And then, how about substituting them? Yeah, okay, I would like to substitute, but I find that acceleration term and displacement term is only different by 1 omega square. So if I tag that in, then I will have negative omega square m times a sine omega t plus k a sine omega t. If that's the case, I can factor out a common term. Here is plus k times a sine omega t equal to 0. 好，同学看到没有？我们这是一维的哦。一维的话，能找到什么？只有一个自由度，它会告诉你。我的振幅会是0吗 ？If I'm going to have free oscillation, is the amplitude going to be 0? 不是0，那要 B 谁是0？右手边是0。这个式子右手边是0，左手边辅值不能0。谁要0？我们那个0，因为它有周期性的，我们那个不会是0。我们那个就是这个两个派除以周期，那现在 ，OK， you have limited choice. The only choice is this whole expression is 0. So in that way, you find your natural frequency. Omega is equal to omega square n is equal to k. So your omega is equal to the square root of k over n. Okay. And next, so how about extending this method to multiple degree of freedom? Okay, I already have a time going through with you on this because that's the one easiest for you to understand. Okay. The next question I have is I have the K1 supporting n, K2 supporting another n. I have displacement U1, U2, U3. Okay. U2 spring K2 U2 U3. Okay. For element 1, okay, you have what? You have K1 minus K1 minus K1 K1 U1 U2 equal to force 1 force 2. Okay. For element 2, you have your K2 minus K2 minus K2 K2 U2 U3 is equal to F2 F3。对不对？大家这些都很熟嘛，对不对？然后这个时候 ，OK， 这个质量出现了，哎。U2 dot is N U3 dot. And what is the equivalent acceleration force? The inertial force is opposite. This is minus N U2 dot. This is minus N U3 double dot. So if you're going to do that sum, you will do the sum. Force sum is F2, F1, F2, F3 is equal to, on top you have the reaction force, on bottom you have nothing. And then on top, you're going to have no mass, but you have minus mu double dot, minus mu double dot. Okay, is equal to what you have. You have your U1, U2, U3, then you have K1, minus K1, minus K1, K1 plus K2, minus K2, 0, 0, minus K2, K2. Okay, 大家看到没有？站在你已经学过有限元素的感单元的方法 ，OK。实际上要写这个刚度矩阵是非常非常标准化的方法 ，OK。所以你想都不想 ，OK。不像刚才，老师可能就来提学例比了，现在你用有限元素法改的刚度矩阵，连想都不想，基本上就填空，就矩阵填空。OK， 然后唯一要想的是什么？你的这个惯性。OK。So now, yep. To simplify, let's see how I'm going to do that. Let's draw it over here. Okay, so to draw them, okay, let me move these to the opposite side. How do I move? In order to move it, I'm going to write the inertial force vector as U1 double dot, U2 double dot, and U3 double dot with mass on the diagonal term. So this is equivalent. So now my equations will have 0 and 0, 0, 0, 0, 0. U1 double dot, U2 double dot, U3 double dot. Okay, plus this is the K1 minus K1 minus K1, K1 plus K2 minus K2, minus K2, 0, 0, K2, and then it's equal to times the U1, U2, U3. Okay. Right hand side is going to be equal to my reaction force. 看到没有？ omega 怎么找 ？OK， 我们记得你要找的话，你只能找非零的位移相关。So in this case, so what is the equation? Okay, so this is for your dynamic equations that help you to determine the natural frequency. Okay, so then you add them up, then you have n0, 0, n, u2 double dot, u3 double dot, plus k1 plus k2 minus k1, minus k2 minus k2 k2, and then u2 u3 equal to 0, 0. Okay, in this case, 还是刚才我们叫你们测针法，我不是问你，这个上面这个嘴唇跟下面这个是嘴唇，它是其上其下还是一上一下，对不对？怎样画？那都是振动啊，振动怎么画？上下，这个振动怎么画？上下，差在哪里？差就差在它振幅啊，是 A1， 这是 A2。So in this case, the displacement U2, U3 will be written as the difference in amplitude. Okay, A2, sorry, let's say 1, A3 and sine omega. Okay, so the phasings, the time they take, the periods are the same. Phasing will be different, one up, one down. Okay, so if that's the case, how am I going to find the acceleration? Okay, I already have the displacement. Then just do the time differentiations. U2 double 1 dot, U3 1 dot is going to be no change to your amplitude, but change to your plus cosine omega n. Okay? If you do accelerations, if you do differentiation 1, you find the accelerations, then you have amplitude no change, but the sine function, cosine function become minus cosine function times omega, then you have sine omega t. So in a way you can say this is minus omega times minus omega squared times u2, u3. Okay? So since that's the case, if you substitute the two equations, acceleration term and the displacement term into this, then you have minus omega squared n 0 n plus k. That is your k1 plus k2 minus k2 minus k2 k2 times your amplitude a2 a3 sine omega nt. Right hand side is 0. 所以同学看到没有？就是大家很熟悉的这个方程式嘛。如果说右手边 力是0，力下来是0，你的振动幅是非0，那什么要等于0 ？OK， 所以我们就是找，这个不是大家很熟悉的负欧米伽 n 加 k 加 k2，然后减到 k2，然后这个负 k2，负欧米伽square n 加 k2，然后 a2 a3，然后右手边是0，然后前提是什么 ？a 不可以是0嘛，对不对？我们看到的振动 ，if a cannot be 0, how do you get the answer? Let's apply the Cramer's rule. 对，学到现在大家应该很熟悉这个矩阵的标准作业。所以我就假定不要用高斯的消去法，我们继续用 Cramer's rule， 那比较简单，对不对？然后 A2 是什么 ？Plus amplitude。A2 is minus omega square m plus K1 plus K2 minus K2 minus K2 minus omega square m plus K2. Okay. So this is your denominator. Then what is your numerator? Your numerator, okay, is by replacing the first column with the fourth vector. What is the fourth vector here? It's 0, 0. Okay, no choice. Okay. No matter how you draw, okay, your numerator is 0. 来，同学，来到这里，请问要怎么确定幅值非零？是有振动的。来，辅助，就你了。式子写到这里，怎么确定 A2非零？什么条件下 A2非零？影片我也给你看啊，振动就是有，振幅肯定非零。
振幅肯定
啊？然后这个式子又分子都跟你两个零。
所以它应该就是零。
啊？什么东西？
它应该就是零。
什么东西零？
它上面分子是零。
但是实验告诉你，不是零啊，振幅都非零。那有些人是不是都跟你讲过了？验证一切真理的方法是实验没错，那理论错吗？那还没有回旋的一点。这样的情况下，看那个分母，in this case, there are chances that your theory will come to a complete. Okay? This ratio of 0 to 0 will make sure A2 is non-zero. Okay? This is non-zero. Okay? So, what's the condition? Then your determinant must be 0. So this is what equation? The frequency equation. Okay? It's telling you the oscillations will happen if that oscillation frequency is obtained from the expression above. Okay? You can solve the quadratic equation for omega squared. Okay? And somewhere you got 2 omega squared. One is omega 1, the other is omega 2. Okay? 看到没有？我们现在用有变数法，把惯性力转换成一个矩阵，那就产生了一个正的质量矩阵，然后加速度乘在一边。Okay, in that way, then you can find the natural frequency. Okay? Yeah. So I hope you are able to do this. Okay? Okay, anyway, for your smartphone letters, not that complex. It's only 1 degree of freedom. Okay? Because your headphone is far more heavier. Okay? Unless you're going to have the robotic dog. Okay? Where their body weight has a substantial contribution from the leg, because the leg have a motor. Okay? Then the leg is going to have substantial mass. Then you're going to have 上到这里，我们只要求你，把一维的自然频率搞定，那你就可以拿来分析你的这个起落架，去预估它的这个撞击的加速度。所以那个是用来跟你们实验验证有没有预计你会用动态分析去模拟这个掉落实验，但是你就从实验跟简单一维的模型比。好，So with this, then we are done for today. Thank you for attention. And next week onwards, then we're going to